Imagine this. You have two twins who come from the same fertilized ovum, one named April and the other named May. April lives a perfectly healthy lifestyle and has no health issues whatsoever, aside from the occasional cold. May, on the other hand, deals with depression, diabetes, and even lung cancer. Both twins share the same genetic information, the same genetic code, so why are they so different? To explore this question, let us take a look at the definition of identical twins. Identical twins are a pair of twins who develop from the single ovum and therefore have the same genotype and resemble each other closely. But this is where it gets tricky. If two individuals have the same genotype, why would they resemble each other closely? Shouldn't they be exactly the same? This is the concept of epigenetics, or the study of non-genetic influences on gene expression. In this video, we'll be exploring two applications of epigenetics and what they mean for us. Our first application will be the study of diet on the expression of our genes. In 2008, scientists wanted to study the effects of high blood glucose levels on the body. Mice were administered short, high doses of glucose every day starting the 10-month study, and very quickly, after only 6 days to be exact, long-term vascular damage with genetic origins was observed. Now imagine what high blood glucose levels could do to our bodies after 6 months, or 6 years. Another risk of high blood glucose levels is damaged telomeres. Telomeres are the ends of our chromosomes which protect us against the effects of aging, cancer, and other genetic mutations. As high levels of glucose destroy an individual's telomeres, that individual becomes more prone to the effects of aging, cancer, and even other life-threatening conditions. But there is no need to cut out all glucose from your diet. Eating a cookie will not give you cancer. As it is often said in the food and nutrition community, sugar in moderation will not harm your body. Our body needs sugar to function. We just need to be mindful of what we are putting into it. For those individuals who have suffered genetic damage from high blood glucose, negative effects of food consumption can be reversed or managed with a low-calorie and low-carbohydrate diet called the epigenetic diet, in which an individual consumes food which provide their body nutrients good for their DNA. These include broccoli, turmeric, and even wine. Our next application is the effect of cigarette smoke on the expression of our genes. When an individual smokes, their body experiences methylation, which is when methyl groups are added onto the end of an individual's DNA sequence. This causes the individual to be more susceptible to genetic mutations, as methylation causes the prevention of certain genes, which leads to an increased risk of lung cancer. In one particular study, human bronchial cells were placed in liquid smoke, which is a simulation similar to smoking 1 or 2 packs a day. Over the next 10 to 15 months, scientists observed changes in the cells and their DNA sequences. After 10 days, the cells had experienced significant DNA damage, and after 3 months, they experienced 2 to 4 times the amount of the EZH2 enzyme, which is an enzyme that suppresses tumor-suppressing genes, which means that the cells were now more likely to not suppress tumor development, which means that the cells were more likely to develop into tumors in the long run. As observed in this study, cigarette smoke literally causes the body to become more susceptible to mutations, tumors, and cancer. So, what does this mean? As stated by Dr. Davis Perlmutter, the choices we make can forever transform our genetic code. It is important to keep our DNA healthy, just as we do our body. Paying mind to the substances we put in our body and the environment we put our bodies in can help us preserve the thing that makes you uniquely you and me uniquely me.